Okay. Hi, everyone. Welcome to the Marketplace Theatre and this presentation called Pure Storage and OpenStack, Eating Your Own Dog Food. So my name is Simon Dodsley. I'm Technical Director at Pure Storage, big OpenStack advocate and open source contributor. And this is Daniel. Introduce yourself.
I'm a Linux systems administrator. I work with Linux, and if it fixes, I break it, and I make more stuff to fix.
Cool, thanks. So obviously we provide block storage, so the thing I'm going to talk mainly about is Cinder, all these lovely little logos we've had over history of the Cinder project. Cinder's very complicated to a certain extent. There is so much choice out there. So what you've got to think about is, if you're wanting a block storage product, you've got to think about a load of different things. There are 98 different drivers out there from 31 different vendors. That's a lot of choice. Only then, or even then, you've got to work out which functionality you want to use in Cinder. There are 20 different functions, 11 mandatory for any Cinder driver, and then there are 9 optional ones. And those optional ones, some vendors support them, some vendors don't support them. Okay. Some of those features that are optional are things like QoS, replication, consistency groups, revert to snapshot is a fairly new one, multi-attach is another one that's fairly new. So when you're thinking about Cinder, block storage for your OpenStack cloud, really think about all of the different features you want, all the different features you need, because that's not necessarily the same thing, okay? And then go look at the vendors. Now, obviously, we're going to say use Pure because we support a lot of this stuff. But you've got to work out, even if some vendors say, yes, we support this, are they just ticking a box? Do they really support it? Do they have a good implementation of that particular feature? Okay, so we like to think that we can do some really good implementations, and Daniel's going to talk about some of this stuff anyway a little bit later. Pure's been working with OpenStack for quite some time now, and we're very proud that we actually don't just contribute to Cinder, which you would expect as a storage company. We contribute to at least 19 projects so far within the OpenStack umbrella. 20 if you count our Manila driver. It's not upstream yet. We'll get it there upstream, and then we'll be 20. But we've contributed some cool stuff in general to the whole of OpenStack. We've contributed the glance image cache for Cinder, written by that guy there. We've also done a whole bunch of stuff in Nova to fully support thin provisioning, trim and unmap, which in the case of a flash array and any sort of thin provisioning array is incredibly important. You've got to get that space back when you delete the files, otherwise you're not going to get the full advantage of, in our case, the flash and the performance and the capacity reductions that you get from that. And we've also added some stuff to the KVM front-end QoS to give you more feature functionality, more capability of doing control of your volumes. So I'm going to have to talk about the flash array. The sales guys will probably shout at me if I don't. So the flash array is our main block storage product that we have. It's a thin provision device. Does data reduction, which is both deduplication and compression. That's on all the time. And what we're getting across the whole of our fleet of thousands of arrays around the world is an average data reduction of about 5.5 to 1, which is pretty good. Now, in a more virtualized world like an OpenStack, you're probably going to get higher than that at the end of the day. So you get a lot more bang for your buck out of the array. You can buy a smaller physical array to get more data on it, which is nice for your footprint, nice for reduction in power costs and things like that. Encryption. It's an always-on encrypted array, AES-256. We fully support snapshots. We support consistency groups. Our snapshots are zero space, so if you take a snapshot of one of our volumes, whether it's a 1 gig volume or a 25 terabyte volume or a 1 petabyte volume, the snapshot is exactly the same size. It is a instantaneous snapshot. You can have multiple snapshots of the same volume. You can recover to any of those individual snapshots. It's not like a snapshot tree where you have to go through the tree to do recovery. Okay. Glance image cache works really well, basically because we wrote it. So that's a really cool feature. That allows you to really reduce your spin-up time for your Nova instances. So instead of having to wait for Glance to start copying things around all over the place in the background and recreating volumes and DDing your QCal volume onto your back-end device, we can just instantaneously snap a gold copy, makes it immediately available to your Nova instance for booting. So bring your boot times down from minutes to seconds, literally. And also we fully support replication within Cinder, and we support both synchronous and asynchronous replication. So that's enough of the sales pitch. Let's talk about eating your own dog food, and hand it over to Daniel.
Thanks, Simon. So I'm the systems administrator. I don't handle sales at all. They put me in a little cubicle and I get to work with computers all day. But they drugged me out for this conference so I could tell you how we run OpenStack. So we started about 3 years ago, and what we wanted to do, that is the wrong button. What we wanted to do was reduce our dependence on VMware. We used VMware a lot internally. And we also wanted to bring down the costs and be able to use a more diverse hardware set. So we set out to accomplish those goals. And as a Sys admin, when I set to look at a product, I only care about two things. One, does it work? Am I going to get paged in the middle of the night? Am I going to curse the sales guy that talked me into it? And two, what's the cost? Because ultimately, you know, the greatest products in the world, they can be great, but if you can't afford them, it doesn't really matter. And OpenStack, luckily, fulfills both of those boxes. So we set out a demo cluster, and we tested on Liberty, was our first release that we tested on. We also tested Overt, and we looked at straight KVM, and we decided that OpenStack was the best solution for us due to the community and the drive behind the entire project. So we deployed Mitaka as our first production release, and it went really well. We did a rolling upgrade to Okata with minimal downtime, and we have on the roadmap this year to upgrade to the latest. We deploy everything just using Puppet, the Puppet modules. We do nothing special. We don't run any fancy distributions. We just code some Puppet, use the modules, and roll with it. We're not the most elegant solution, but it works great. Currently, we have about 200 compute servers spread across 2 data centers. And we have 4 flash arrays, 2 per data center. Why do we have 2 flash arrays per data center? Because they get lonely if you buy just one. So you want to buy at least 2 flash arrays when you buy a flash array. 2 just seemed like a good number. Why have just one? Some things that we do that are unique. We use Nova availability zones in completely the wrong way. And this is because it's easier for us to tell a customer inside of our group, to tell a development team, look, you want some resources, you provide us with some hardware. So they'll buy 5 or 6 servers. But then the question is always, well, am I getting my 5 or 6 servers worth? And so we put them in an availability zone. We put all their servers in the availability zone, and we say, look, all your servers are yours. If you max them out and they're running slow, it's your fault. If they're not running fast enough, your fault. Buy us some more servers. And that works really well because it kind of puts the budgeting constraint back on that team. They're not complaining, and we're not just sort of buying a bunch of servers that everyone leaves powered on and running because they forgot about all those instances. Some other things that we do that are different, we use NUMA awareness and CPU pinning heavily. And the reason for this is we have a lot of virtualized instances of the OS that runs our storage product. Purity is what it's called. And so to test Purity, we have a lot of physical hardware, but that's always expensive. And so we do some earlier testing on virtual hardware. And what we ran into with VMware and a couple other things is that we would have contention issues and tests would fail. And we don't know if the test failed because we made a change in the code or because it was simply the virtualization platform, you know, live migrating something or something went wonky on the background. So by pinning the CPUs and pinning the NUMA zones, we get dedicated memory bandwidth, which means we don't have to worry about, was this a NUMA awareness issue or was this just we coded some bad code? And we also get as close to physical hardware as we can get. Does that reduce our oversubscription? Definitely. But for us, the trade-off is worth it because we get essentially very, very consistent run times. Every developer knows that when the job ran, and if it had an issue, it's their code. It's not the underlying virtualization platform. We run over 1,100 Nova instances. It's not a lot. I know everybody here runs a lot more, but you know, I don't know. There's always small companies and there's big companies. Another use case that we have is we run what are called XL Dev VMs for developers. So I have yet to meet a developer that can get enough cores or enough memory. And if you're like me, you probably, all your developers are the same too. So we give them a 40-core instance with 128 gigabytes of memory. And on the back end, we're deduping the memory using the KVM memory dedupe, because nobody actually uses all 128 gigs. They just want to have 128 gigs in case they need it. Same with the 40 cores. So we have 40 cores available, but what we're really using them for is a build compile type cycle. We want the developers to be able to compile as fast as possible and then go back to idle. So we can heavily oversubscribe the CPUs as long as they're not running long-running jobs, which works well. Most developers are okay with that. They recognize the trade-offs inherent in the fact that we can't buy everyone $50,000 worth of hardware. So Cinder, we love Cinder. I love Cinder. It works great with our flash arrays. We only use Cinder volumes. We don't deploy any image-based infrastructure at all. In fact, our compute nodes only have 40 gigabytes of space to keep anyone from inadvertently running an image-based instance, because it just doesn't work. We don't have the performance on the local machines. We have the performance on our storage arrays, which work great. We use the volume where scheduler, basically because that was the closest thing to a round robin. We don't worry about performance on the flash arrays because they can handle anything. So all we worry about is, do we have about an equal distribution of load on each of them, and the volume number where fulfills that the best. Like everyone, we probably use multipath, we use iSCSI, we use some bonded trunks. There's nothing special there. We did have some issues initially with deploying Purity. So as I mentioned, Purity is our OS that runs on the flash arrays. And in order to have it fully virtualized, we have an alternate partition, a boot partition. We have a bunch of different stuff so that you can, we never want the array to actually die. And so to test all of that is a 14 gig image. And we looked at trying to reduce the size of the image because it takes forever to deploy on Glance. It would take about 10 to 14 minutes to deploy that. And this is where the Glance image cache came in really handy that we wrote, which I didn't even know we'd wrote until Patrick said, hey, we wrote this, because we don't actually talk. I run my own stuff, he runs his stuff. But anyway, once we turn that on, the first deploy, sure, it takes 10 to 14 minutes. But after that, everyone is basically an instantaneous snapshot of the LUN and then a clone. And that takes less than 20 seconds to deploy an instance. So we will deploy hundreds of Purity instances, and the first one takes 15 minutes. After that, the cache is now populated, and we don't change the image that often. Every subsequent one takes less than 20 seconds, and it's a real time saver. Not everybody has giant images. I know you all optimize your images, but there's always that one-off, that Windows project that needs a database loaded in and is 20 gigs. And for that, the image cache is really handy. So we have about 700 volumes that we create and destroy each day. The arrays handle that just fine. Cinder handles that just fine. We do have some legacy code that uses a VMware, what we call snap reset cycle, where we would snapshot the VM and then we would reset it. Unfortunately, that wasn't a feature that OpenStack had at the time, and it sounds like they do now with the new kind of snapshot restore thing. But for that, we use some custom code. So we just talk to the Purity REST API, and we'll use Nova, and we'll shut down the instance. Then we'll just reset the LUN underneath it. Cinder doesn't know, nothing's changed. We just kind of flip the bits on the back end of the array, and we power it back up. And that is really, really quick. That's probably our fastest way to actually reset things, and it works really well. We're happy with that. So most of the people who use OpenStack at Pure don't even know it. All they're using are instances that we're running on there. We deploy and manage the instances for them. They don't ever touch the OpenStack GUI or the CLI or anything like that. But we do have a couple of teams that actually use OpenStack as a normal OpenStack user would. So they have access to the CLI, they have a project, we give them their availability zones. And for them, they love this. The main compelling reason for it is they have more local control over their instances. They can say, look, we want this custom setup. They can give us more hardware, and there's no big bill because at the end of the month, AWS is always going to charge you. Are there costs? Sure, but we're already running a data center, so us adding a couple more machines for them is really minimal overall. We actually pulled back usage from AWS into OpenStack, and that saved us a considerable amount of money. And those instances are also heavily oversubscribed. So these people are crazy, in my opinion. But they will put 100 instances on a 48-core, 512 gigs of memory machine. And I think it's too much, but they're happy with it, or at least not buying me more machines and throwing them at me and saying put them in. So overall, it works really well, even heavily oversubscribed. And again, this is all Cinder backed. We have thousands of Cinder volumes, and they work fine. Our goals overall with OpenStack and the whole project, and the reason why we did this, were threefold. And we wanted to reduce our vendor dependence. We no longer have a single virtualization vendor now. We have two. We still run VMware. We like VMware. We use VMware heavily. We support it. But we moved a lot of our less important usage into OpenStack and into projects that can use the flexibility that OpenStack offers. We've also saved over $1 million in VMware licenses, which unfortunately I do not get a cut of. And going forward, the plan has always been that we're going to hold the VMware licenses level and increase the OpenStack usage. So OpenStack worked really well for us. If you'd like to talk about how we work with OpenStack and Pure Storage, you can come by our booth at A10. And if you have any questions, you can come see me. I'll be at the booth, and so will Simon.
Okay.
Thank you.